Okay, so let's talk about the first test for infinite series. The first test being the divergence test. This is typically the first test you'll go to when you're looking at a problem. It's one of the easiest. So you have, the way it works is you'd say you have a series and some sequence. What you're going to do is just take the limit as n goes to infinity of the sequence. Just the sequence part of the problem, not the whole series. And if this is not equal to 0, then this implies that the series diverges. And that's all you get. If the limit is 0, the test is inconclusive and you have to try something else. That's why it's called the divergence test, because that's all it tells you about is divergence. So we can look at a few examples, but it's a relatively straightforward test. Okay, so we take the limit, so n goes to infinity, of just this sequence part. And then remember how to take limits of rational expressions. You just consider the highest power terms. So n squared over negative 17, n squared becomes negative 1 over 17. And this limit is negative 1 over 17. This limit is not 0, therefore we have our series diverges. So a lot of students ask me about this problem, the series of 1 over n. So one thing to keep in mind is the difference between a sequence and a series. So the sequence of 1 over n would just be the listing of numbers, well, assuming that you're starting at n equals 1. It would be the sequence of numbers 1 over 1, 1 over 2, 1 over 3, 1 over 4, and so on. The series would be the sum of that sequence. Just adding up all those terms. So it's very easy to see as n gets super, super big, the sequence goes to 0. It is not easy to see what the series is doing as n gets very large because you're adding up numbers. So know the difference between a series and a sequence. Okay, so looking at this problem, if we try to take the limit as n goes to infinity of just the sequence portion of the problem, that should be obvious that this goes to 0, and therefore the divergence test is inconclusive. Why? Because the limit has to be anything other than 0 for you to conclude that your series diverges. If it is 0, you have to try something else. Let's try another example. let's take the limit as n goes to infinity of just the sequence portion. And again, remember how to take limits of quotients of rational, or how to take limits of rational expressions. So this is going to be infinity. I have a video on limits, a little bit of a review on limits that you can check out if you want, just to review. But this limit goes to infinity. It does not go to 0. So because it's not going to 0, we can conclude that our series diverges. And the test is really this easy. Let's try a couple more. Okay. Let's look at this series. So again, we'll try our divergent test because it's the only one we know so far. And we take the limit of this sequence which is the same thing as taking sine of the limit of the sequence. Okay. From this point, we should be able to tell that the limit of the inside, if you look at just the highest power terms, n to the fifth and n to the fifth, the limit on the inside just goes to pi over 2. And sine of pi over 2 is 1. So again, this is not 0, so we can conclude that our series diverges. Okay, let's look at one more. Okay, so take the limit as n goes to infinity of the sequence. Okay, oops, this should be an n. Okay, so there's a problem in this case because the top function is going to infinity, the bottom's function is also going to infinity. And there's no real way to clean that up. So remember that when you have a function of this form where you're getting infinity over infinity or 0 over 0, you can use L'Hopital's rule and take the derivative of the top and bottom. We're going to be a bit lazy here and take the derivative with n's. You're not supposed to do it that way, but it's going to work out the same. So the derivative of the top is 1 over n plus 17. The derivative of the bottom is 1 over n. This is not a quotient rule. You take the derivative of the top, you take the derivative of the bottom separately, and then take the limit of that quotient. So we're going to clean this up a bit. Dividing by 1 over n is the same thing as multiplying by n over 1. So this becomes n over n plus 17. And we're going to take the limit of this instead and get 1. So our limit is 1. It is not 0, therefore series diverges. Okay. The limit n goes to infinity. Oops. How about the series of just n? Well, so we take the limit as n goes to infinity of the sequence n. Well, obviously this just goes to infinity, therefore our series diverges. So that's the divergence test.